Welcome back to today's Explainer, everyone. Take a seat because today we're evaluating humanity's current energy crisis using the ultimate cosmic grading rubric. I'm really thrilled you're here because what we're looking at today completely redefines our place in the universe. We're going to intersect astrophysics, computing, and thermodynamics to understand a very real, very pressing deadline that humanity is facing right now.
Okay, here's our syllabus for today. We're going to start with the classic scale, uncover a flaw in the math, look at measuring information, push to Landauer's limit, confront the AI energy crisis, and finally, arrive at the crossroads. Let's jump right in.
Section 1. The classic Kardashev Scale.
So, as you probably already know, the Kardashev Scale grades a civilization's maturity strictly on the sheer quantity of watts it can collect and consume. In Kardashev's time, we're talking the 1960s here, the assumption was pretty simple. More power equals more progress. It didn't really matter what you did with the energy or how efficiently you used it, just that your civilization could harness a massive amount of it.
The scale envisions a progression through 3 distinct stages. First, you've got your Type 1 planetary civilization that can harness all the energy of its homeworld. That's about 10 to the power of 16 watts. Next is a Type 2 stellar civilization that increases that output by 10 billion times, eventually building megastructures like Dyson spheres to capture the entire energy output of its star. And finally, a Type 3 galactic civilization, literally harnessing the energy of an entire galaxy.
But here's the reality check. Humanity is currently failing this cosmic test. We're sitting at roughly a 0.7 on the planetary scale. We haven't even mastered our own planet's energy output yet. But, as we're about to see, grading ourselves purely on raw power, that might just be the completely wrong approach entirely.
Section 2. A flaw in the math. See, Kardashev originally predicted we'd reach Type 2 status in about 3,200 years. But to get that number, he incorrectly assumed a steady, uninterrupted 1% energy growth rate. When modern researchers actually looked at 60 years of real-world data, they found this model was an extremely poor fit. We're actually looking at a volatile reality of closer to 2% growth, which gets heavily disrupted by unpredictable black swan events. I mean, just think about how the COVID pandemic suddenly completely shattered global energy consumption trends.
So, the crucial point here is that if we try to fit our current progress into a simple linear energy model based on actual data, the math totally breaks down. It would take us 1.6 quadrillion years to reach Type 2 status. To put that into perspective for you, that is vastly longer than our sun will even exist. Clearly, just looking at how many watts we create just doesn't work anymore.
Section 3. Measuring information, not watts.
Back in 1973, the legendary Carl Sagan hit the nail on the head and gave us the missing variable. He argued that you just can't measure a civilization by its power plant output alone. An advanced civilization must also be judged on its information processing power, basically how well and how fast it can communicate and transmit complex data structures.
To prove Sagan's point, recent researchers proposed a new model utilizing the Bitcoin network's hash rate as a rigid, unforgeable thermodynamic yardstick of proof-of-work computation. And honestly, when they analyzed data from 2009 to 2024, the results were absolutely staggering. Over those 15 years, our global energy production barely increased by a factor of 4, but our efficiency in turning that energy into organized information, what the researchers termed a Kardashev unit, exploded by 14 orders of magnitude. That's an increase of roughly 100 trillion. We didn't just build a bigger bonfire, we learned how to make the fire incredibly smart.
Section 4. Reaching Landauer's physical limit. Proposed in 1961 by Rolf Landauer, this principle bridges the digital and physical worlds. It proves that information is literally physical. When you erase a single bit or force a 1 into a 0, you create an entropy transfer. To satisfy the second law of thermodynamics, that lost entropy can't just vanish into thin air. It must be exported into the environment as unavoidable heat. It's the exact same reason your gaming laptop turns your dorm room into a sauna when you're running heavy software.
Now, for decades, this was seen as purely theoretical because our computers were just so woefully inefficient, dissipating billions of times more heat than this limit. But as silicon transistors shrink, we're rapidly closing the gap toward that absolute physical minimum at room temperature, 3 × 10 to the negative 21 joules. Therefore, a true Type 2 civilization wouldn't just be a society burning endless watts of star power. They'd be a society that hits the staggeringly small physical limit, conducting ridiculous amounts of calculations while barely generating any heat at all.
Section 5. The urgent AI energy crisis. Historically, energy demand just kind of trickled upward. But right now, while general global energy use grows at about 2%, the sheer computing power required for the artificial intelligence boom is driving a staggering 15% annual electricity growth. This demand is completely decoupling from traditional economic trends. If this trajectory continues, by 2050, AI's energy consumption will literally equal the rest of the entire world combined.
And that massive demand triggers a profound physical trap known as the Kelvin limit. Because of the laws of thermodynamics we just discussed with Landauer's limit, every single computation generates heat. So even if we magically wave a wand tomorrow and invent perfectly clean, unlimited hydrogen fusion to power all these AI data centers, the second law of thermodynamics dictates that every single bit of that clean energy eventually converts into inescapable waste heat.
Which brings us to this incredibly shocking timeline from recent studies. Listen to this. If AI continues its rapid 15% expansion, the sheer volume of energy demand will exhaust our traditional resources like fossil fuels and uranium in just a decade. But it gets worse. Even if we unlock fusion and use all the deuterium in the ocean to power it, in just 67 years, the sheer volume of inescapable waste heat generated by those computers could literally boil the oceans. Yes, boil them.
Section 6. Humanity's cosmic crossroads.
As students of this cosmic syllabus, we have to recognize our options are suddenly very, very limited. To survive this immediate energy crunch driven by AI, we're forced into one of three distinct paths. Path 1, we suffer a total planetary collapse from thermodynamic waste heat. Path 2, we rapidly expand into space, become interplanetary, and build a Dyson sphere to capture solar energy away from our fragile biosphere. Or Path 3, we urgently shift our focus completely away from raw power and achieve perfect computational efficiency down at Landauer's limit.
And, this reality neatly solves one of the greatest mysteries in astrophysics, the Fermi paradox. Why don't we see advanced aliens? Well, science fiction taught us to look for giant, glowing, highly visible factories and megastructures. But the scientific reality of thermodynamics suggests that a truly advanced Type 2 civilization wouldn't look like that at all. To survive, they had to become perfectly efficient, silent, and barely visible information processors, operating exactly at that Landauer limit. They're invisible to us simply because they're ridiculously good at managing heat. So, as we chart our syllabus for the future and wrap up today's explainer, we really must ask ourselves a profound question. Is our volatile, energy-hungry transition into the age of artificial intelligence the ultimate great filter? Are we about to boil our own planet in the pursuit of machine superintelligence, or will we master the thermodynamics of information and quietly take our place among the stars? It's the ultimate final exam, and humanity's cosmic fate depends entirely on the answer.